Hello, mentors. Let's use our hands to illustrate moves equations. So this is in part 2. When we're doing the symmetry with color, this murals activity, and we're trying to justify why we get these equations with moves. So this is a little informal, and it's just to illustrate. But I guess the value is that it's very hands-on, honestly, and that everyone can try and have fun. It just involves the body. You can use hands, but you could also use some other, body objects or just objects all around, like your cell phone, etc. So just be creative and hands-on. Let's start with this vertical axis flip plus vertical axis flip. That's the identity. So you use your hand, and during the video, you can pause at any time, and with your actual hand, do these moves to check that you get the identity. So if we do a vertical axis flip, starting which is with this hand in this position, just like that, just do a vertical flip, axis flip. So you'll get this, right? And if you then do another vertical flip, okay, you cannot twist your arm, but it's kind of just going back to the initial position. So let me just erase this here or move it here. You would get this. And you can see that that's just the identity. So here you could just put the identity doing nothing. So we actually get the equation. Two flips cancel each other, just the identity. Okay, what if we do two horizontal flips? Okay, it's a little more uncomfortable maybe to just flip your hand, but you can do it. So it would just have your fingers pointing down, and you would now won't be able to see your nails, right? So just like that. And if you do it back again, don't get injured, please. Just go back, I guess, to the original position. Another time. Okay, so we get the identity. So this is done. Half turn plus half turn. Okay, if you just rotate, just do a half turn. So don't flip now, but just rotate 180 degrees. You'll get this. And if you do it again, without getting injured, please, you go back to the same. So you get the identity. Okay, so those are easy equations. Then let's do the other two. What happens if we do a vertical axis flip and then a horizontal axis flip? So we do two flips that are different. Okay, the first vertical axis flip gets you in this position, right? And now you do a horizontal axis flip. So now you're able to see your nails, but now you point down. And you just realize it's exactly the same as doing a half turn. So this equation gets our validation, at least from hands. What happens if you do a half turn and an horizontal axis? So first, if you do a half turn, let's go with this. Let's do first a half turn. So you're still be able to see your nails. You just point down now. And you do now a horizontal axis flip. So horizontal, okay? So your fingers now point upwards, like this. And you just realize that that's just a vertical axis flip in summary, right? So it's kind of efficiency. You could also tell your students that doing many different things, you didn't need to. You could just have done a vertical axis flip. That's kind of the idea. So you get the same outcome. And what if we get to do all these three? What happens? Oh, sorry, let me go back here just to get my. So let's do that. Let's first do a half turn, okay? So that'd be just rotating, right? After the half turn, let's do a horizontal axis flip. So if you do a horizontal axis flip, so what happens? Oh, sorry, this one. And now let's do finally a vertical axis flip. So vertical axis, you flip it. Just think about it. You would get this. And it's like doing nothing, right? It's the identity. So this equation gets verified. These are just samples because you could have many different. But so for generalizations, we could say the following things. So for the three symmetry moves that we just considered, so horizontal axis flip, vertical axis flip, and the rotation 180. So each of them is equal to composing the other two. And you can check that the order doesn't matter in any order. What this means is I could have just put horizontal first, and I would have gotten the same result that you can check. And then doing all three of them. So each exactly once in any order gives you nothing. So the identity. So that's a cancellation equation there. And I guess doing each twice gives you the identity. So those are three important rules. So it just becomes an algebra of transformation and algebra of moves. And these are, I guess, the main equations or the main properties that they could have. So what happens is that if you have one symmetry, let's say a shape has both B flip symmetry and horizontal axis symmetry, then doing what happens if you do for that same shape, if you do the half turn, that half turn is the same as, so we just use this equation, right? Is the same as this. But if the shape already had symmetry for vertical and horizontal axis at the same time, then this is equal to, so same as identity twice, right? Done twice, because this is the identity. So this is doing nothing to the shape, right? It's leaving it alone, leaving it the same, just identical. This also. So if you do it twice, this is the same twice. So the conclusion here would be that half turn does not change the shape. That shape is also left the same. So the conclusion is that if you had two symmetries, then it also had the third symmetry. So you can never have exactly two symmetries, like a domino effect. It makes us fall. It makes us the third symmetry also happen, which goes back to this table here in part one, in which you couldn't have exactly two yes, either zero yes for some shapes, or all yes, or just one yes. So hopefully that illustrates the point with some visuals. And again, you could also use Cartesian coordinates for some advanced students. So just check how far your students are willing to go and are able to go and motivated in generalization. This is just one step in visualizing all this algebra. Okay, so I hope you enjoyed the meeting. See you in the next video. Goodbye.